Hello everyone, welcome to another week of Cybersecurity 360, a series of webinars conducted every Sunday. A series of webinars conducted every Sunday by the Digital Privacy Forum. So, for those who don't know about the Digital Privacy Forum, we are a group of cybersecurity with a core goal and to connect like-minded peoples. So, this forum will guide any member who becomes part of it with the end-to-end cybersecurity and about digital privacy. So what you get by becoming a member in this forum? You get an opportunity to network with people around the world. And we also list the top open source tools, which gets updated every often. And you get an opportunity to increase your skills in the cybersecurity domain with proper guidance to how to get the relevant certifications. You get an opportunity for participating in freelance projects, and businesses which have cybersecurity products can also list their products in our website. So if you are a student, a cybersecurity professional, a trainer, business executive, you will definitely think that is relevant to you to benefit from. So if you had not already joined our forum, you can do so at digitalprivacyforum.com. So without much to do, I'll introduce this week's speaker. He's a cybersecurity consultant, and he's currently pursuing his master's degree in information security from Kingston, London. He's an ex-Deloitte, and he's a red teamer. Without much to do, I hand over this session to Jeeva. So guys, kindly enjoy and make use of this session. Thank you.
Yeah, thank you, Rashid. Thank you for the introduction. And good evening, everyone. I hope you got my introduction. So today we're going to discuss about red team and its fundamentals. That's my topic. I'm going to discuss on that particular thing. So okay, getting to the track now. So what we're talking, it's red team. Fine, okay. I'm just moving the slides. Rashid, you can see my screen, right? Hello, Rashid. Hello.
Yes, tell me, Jeeva.
Yeah, you can see my screen, right?
Yeah, I can see. I can see. You can make it little bit bigger so that it can be visible for everyone.
Fine. Yeah. I hope this is pretty fine now. Well, so getting into the agenda. So where does red team comes into play? So that's the first question everyone has. So like where does it start? Where in the attack kill chain does actually begin? So attack kill chain is something like we follow with the METRI framework. We're going to discuss about red team infrastructure here, like what is red team infrastructure with all the detail coming from command and control servers, team servers of agents, and implant bots from transports, like different transports for these bots dropping stages. How did you actually get the malware on the system in detail? How does all link together after we learned about all the stuff? How does all that come to the fruition at the end? So we'll talk about that. So I just want you to make yourself comfortable, and I want you to understand what we're actually discussing in this particular talk. So I want you to get outside. I want everyone who is attending this particular conference talk to get something out of this, and they can make utilizing these concepts and topics. Yeah. So about the METRI framework, you can just Google it. You can find a lot of pictures regarding that. So once you Google that, you can find attack kill chain picture, and like I'm going to discuss about the second of that's the main portion of what the separate team does. There are red teamers do the entire kill chain. We really only handle the second off, and that's what I'm really going to be talking about, because it's based off the infrastructure for this talk. So we start with what we got to deliver, the malware. We have to deliver that malware or implants onto the target system. Here I refer target system as the victim, either like you are trying to attack with like your engagement, So the target system, we need to find a way to deliver the malware. So we will be talking about that, and we then need to either exploit it in some way to actually get the malware to run, because we can't deliver it without an exploit or vulnerability. So here we'll be discussing about something called project. So one second. Yeah. So we'll be discussing about project team server. Yeah, so this might be really a fancy one for you. So basically, team server is like a C2 server portion of Cobalt Strike. So people who have no idea about Cobalt Strike, you can just Google it. It's a really useful tool what we use in our day-to-day red team activity. So it basically accepts the client connection just like a beacon callback, and mostly like a web request. By default, it accepts the connection from TCP. And so once we exploit either like with I say eternal brew is an exploit, or maybe the other exploit, assuming that we have compromised accounts. So in that case, a compromised account, we can actually can now take control by exploiting these vulnerabilities. And once we exploit these vulnerabilities, we now have control over the system, that we want to execute our stages or droppers for malware depending on what you are doing in the kill chain. Then once execute, you want to maintain the persistence on a device. You want to persist on a device, then from you can do the rest of the red team engagement. I hope you're clear till this particular conversation. So we'll be talking about a bunch of vocabs and a lot of stuffs I say in that on the first slide of the agenda. So here's another brief overview. What we're going to look at the reference of this overview. This is a very, I'd like to bring up some very basic topology, what I made to make yourself understand. 1 second, I'm bringing it down. So this is the very basic topology I made for you. So this is a team server, which handles multiple C2 servers. C2 server is a basically command to command server, and this is a victim mission. I assume like that's our engagement particular target. Yeah. So it can be made very many different ways. You can have one, just a target mission is involved in all these. You can have one C2, and that's you have two C2 and a team server. You can have this one C2 and one team server. You can do a lot of here, but I'm just going to stick with basic one because it allows us to have 2-3 command and control servers. That's really good to go over a bunch of different examples. I have the communicates to target mission, and then team server is going to communicate with those C2s. So this would be, you would be wondering what is the C2 and what is this team server, and it would be really fascinating for you. But I hope you'll get yourself comfortable by end of this talk. We'll be discussing on that. Yeah, so as we assume that target mission, our ultimate goal is to compromise the target mission and making the lateral movement in that particular company or the firm or the other target client. So that's how we goes. So target mission, and then team server is going to communicate with those C2s. We are going to get into what or all these things right now. So let's start the command and control. I think it's a really good start. I'm just moving to the next slide. So basically, it's in the middle layer. So I hope you remember the before picture, like I just kept all the C2s in the middle layer, and I made my team server on the top of that. And you know what? So what the target computer actually communicate with this, what the mission that you compromise. So actually communicate with, so they sit on there and listen. It was like a heartbeat. You can send command to the target and mission with this. You can receive data or any output from the command you use to talk with the team server. So what does the communication is where happening here? So you know what, you'll be telling your target mission to do something. You can handle the target mission. So you want this work to see what level of access you want. So you can check who am I, hey, I'm the C2 server. Okay, we are running in it, and it sends down to the target mission, and then it will run your implant or your malware that you have on there, and say your malware like that is coded back to that is coded to send back the output from that. We'll get the output and you'll see it on the command and control server in some cases. It would be like it will be sending up to the team server. We'll talk about this on next slide. Here, so when you look into the team server, so basically it communicates and it keep on tracking all those C2s. So it's like managing those C2s and it basically collects those information from C2s. And you know what, eventually you can able to it's like we get that helps us to manage those infected missions that's behind the C2 servers. So it's something like heartbeats. So those are really important. So I want this to a lot of times malware be called out like a beaconing. So that would be a really a different term for you. You might be wondering what is this beaconing and all this thing stuff. So you know what? So when the malware actually or the implant talks to the command and control server without actually getting the run of the command, it will just give the nice check, something like, hey, like how are you, like there will be a response like I'm still alive, or you can, that will be communicating with those two servers. So actually getting to the run command, run of the command, I'll just give it so you know what, I'll just keep to find about the all those traffics. So you know what, it will create a lot of network traffic. It's all just a malware still on the system. You can still communicate the C2C server, and that's really key that keep organization on the whole red team infrastructure. It's very similar to botnets. Do they call out like to that server like what's going on? Like it keep on checking with that. So I hope you were really. I got some questions here. Can you run F5 for your running presentation? Yeah, but I just want to make it on different slides, so I'm just sliding it right away. Well, so getting to that, getting back to our talk. So till now, we just got to know how these implants and malwares are going with that, and you know what? Basically, before conducting any red team engagement, we want to make sure, like we want to reduce the noise. So here I call noise as something like traffic. So whenever we are into some other network, there will be different monitoring tool and that will keep on eye. So it keep on tracking what's going there. So if you're running these plenty of C2 servers and team servers, that's going to create a lot of traffic. So you know what, as we discussed, team server is the basic one, so that's going to communicate and it seeds, you know, it collects all the seeds and information from the other C2s and organize those affected missions where it will check whether they're talking. So you know, it would be insane. You can actually do some scheduled task, like you know what, in more popular team servers to run on mission at certain times means certain expectations. You can group missions, and grouping these groupings will be whatever you can set up. You can have it be anything on the section IP address to the run. This time the big thing is keeping servers that do not directly communicate from the target mission. That's the most important thing. So they don't communicate the target mission. So this is the one of the best way to reduce the traffic. So team server is like a way up there in the topology, like in the, like I hope you remember in the slide. So it's in the top of the topology here. Yeah. So you can do proxy. So what is the major reason to do proxy here? So because if I'm doing proxy here, that's going to reduce my noise. I don't want to get caught by some blue teamer who is sitting in that company. So that's our entire goal. So you know what, you could have C2s in between the C2s here. You do not want your target mission, even though your team server exists. So that's the ultimate goal here. So that's the you know what, that it's going to reduce the bot order. So it's basic, like when a lot of contacts do that, they don't even know what's actually talking in the bottom. It's like the actual person running bots does not even though it's like a low level grunt missions. These would be a lot of you know what, people will get caught when they try to make it in a straightaway approach. So to reduce that, um, we know, like, the reason, if we caught, they will block it, they will block us right away. So our whole intention is to reduce those traffics and make ourselves hidden in that particular environment. uh, so as for now, we have discussed about team server and C2 server and the basic topology, how this communicates and all this together. So now, I've been saying the implants, the malwares and botnets, just getting into that. Yeah, so this malware, so this is what this called the C2s and all this thing. So you know what, they use different terms in the community. So I have heard a lot of terms, like people use the interchangeably, they do mean different things to some people. I'm not extremely clear on that, what is exactly specified as well. I just don't use or interchanged so much. So this is pretty much universal term. It is your malware is on system, that's what you're running on the system, that is malicious. Yeah, so this is what calls out the C2. So yeah, this is what I'm referring, what a implant, what is implant, because that's why I say a lot of these implants call out your C2 and actually communicate with it, think, run commands, and they send heartbeats, do all of that. So now I have probably I'll be getting the shell or a target. So there are different types of shell, like one would be a blind shell and other would be a reverse shell. So it's a simple, like what the shell, which means uh, I want to go over the malware specifically, or blind shell. So when you are like, 1 second. So so it's like listening, and so with your target mission, for example, when it comes to blind shell, your target mission will open and it keep on listening and it waits for the connection to be made. It when it's to come, it's similar like SSH. So yeah, so blind shell is more or less similar to SSH, and when reverse shell is something different, like the server machine makes a connection to you and see there are a lot more what you seek at that times. So after running all these fantastic jobs, what else your malware can deal with that? So just running commands, and what you can check for very high level privileges, and our ultimate goal is to install the backdoors. So now coming to the droppers and stages. So there are a lot of people says like, okay, well, how do I get the malware on the system? Okay, well, your proper stage is something you coach, and you would install the implant. This dropper stager is a script or an executable binary file at any sort. It's just has to install your implant for you. So it can change a bunch of settings for you. It can do time stopping. With that, it's changing the system time on the file that you have on there to match other system files. It's kind of way to hide the modified files. You can copy a binary that's safe inside of it. So clarifying with that means, I would like to say, you have a thought like .exe file. You can actually save all bytes on the another exe file inside of your body of exe file, and then you can tell you are the one who is running the dropper to the copy.exe file, and you can make out of itself and put somewhere else on the system to run it. This is where you get some really get great positive executables. You are doing it now, so we'll be looking on that. When you really don't want to have the huge end executables, or alternative is for you can have it to pull it down from the servers. So your dropper will call from the download server somewhere like sort of CND. You will be hosting your file and save on the cloud somewhere else. Then your dropper will be like, give me that file real quick now. So it download and it will install. So this is the all the whole intention of stages is to reduce the file size and make it more non-traceable, not to be tracked by antiviruses. So you know what, whenever we try to some large, there is some message here. The speaker want to move on the slides are intentionally given. No, I'm just moving it to the next slide because I just want to make sure like how the stages goes on here. So this comes transport. So I'll be discussing on this later. You know what? So you see that as I mentioned, like this there where I will be hosting my malware somewhere in the cloud, and I'll be calling that and you know what it will pull that and it will run on that. So as we mentioned, so that's how the implant you know what a C2 and the team server does actually. So the communication between C2 and the actual implant, so that's what the transform we describe in the red team. So there comes to communication, and the C2 just way communicates. It's like there are so many different ways to communicate. It's literally the protocol available here. Like here, I'm going to discuss the transport. So how the transportation actually happening with the C2 and team server. It's like either you can make use of any protocol, or if you can able to make your own protocol with the raw sockets. So we can build command speed at literally any protocol that exists. Like all the time we see like HTTP and HTTPS or enter traffic, you can literally send it to actual HTTP headers, like the request to CT, like you know the command and control that's running on the command control will know. Yeah, so that's how I got the web request, and we can look at the data section and data section command that says who I am. Like it will check on that and it will run and it will talk back to you. So literally like you can transfer data between two servers and target mission. So that's the ultimate goal here. What is the different things you know what when I'm managing two servers on target mission with the web request. So you can make use of DNS here. So DNS, you know, it has an open package you can talk to, and you can do like ICMP mail, you can talk to the mail like SMTP protocol. There are way back to send data between those basic TCP and UDP sockets you do. Yeah, so yeah, even we can able to use botnet with the UDP socket that runs, just takes the command and that will talk to us. That's one way to do it. Even write your full layer raw socket just like protocol from a kernel app. Like it doesn't even touch the firewall, because you know what, which all can be monitored through this. The big problem is now we have all this traffic going through and it could be monitored. So as we mentioned, we need to use some hiding techniques here. Coming to the hiding techniques. All right. So as we discussed back, there were a lot of traffic you could see, and it will be doing everything. And you know what, they can get to know what we are actually doing on that particular system. So you know what, being a red teamer, I don't want you to know what actually we are doing, and I want you to stay here. So what I am gonna do, so this is like we could even just like do some base 64 commands that we are running, and that will obfuscate it. So you know what, it's just encrypting those particular malwares and sending it to that. So it's gonna be in the more way to hide those. And there are some, you know what, you can use a combination of different approaches. And the best thing you can make out here is, so once you got the infected computer, for example, say I have an infected victim computer and I have on my laptop and here that I want to talk to, and I have my other C2 and then a team server. So I tell my team server basically command to that laptop. So I will tell my team server. So victim tells to C2 like a proxy. So you know what, I am making that victim computer from my laptop to run, and I'm just making and I'm making to talk back to the another victim computers. So it's like you know what, this is the one of the best way to hide all this thing, because you know that I haven't doesn't even C2 service go to the victim machine, and maybe victim machines is it on a network, it's supposed to be talking in there anyway. So now you have more hidden traffic. That way also, it's not about to exit sending extreme amount of traffic out as another really good way to stay in the real world. you will not communicate constantly to the computers a lot of times. That's a very, it's an obvious thing. Throughout the network, there will be monitoring software. So you want to make yourself hidden from that monitoring softwares. Yeah, all right. So now getting back to the kill chain here. Sorry. So getting back to the kill chain. So once we deployed our malware successfully in the client or either the dropper which you want to making in the compromise, which you install in the compromised account or some sort of means getting the computer. So we can actually control, and you can make a prayer dropper at this stage. So that allows us to access, and now we wait and run to check your command and control server. So whenever you're running your command and control server, you'll be getting a green light. Hey there, I'm waiting to check your command server and control servers. Once we see the green light, yeah, so we got the access on that. So after getting all this thing, we do to build more backdoors, we extract important sensitive informations. What are the things you want? After getting into this, the real active directory comes in here. So you'll be try to working with different active directory attacks. So like there are more familiar active directory attacks like kept roasting, golden ticket, and server ticket, and you can do a lot of things. And our ultimate goal is to make the compromising the domain. So once we compromise the domain, we can check for the cross first enumeration. There are a few techniques, so we can check out all this thing at the point. So after compromising all this thing, our ultimate goal is to compromise the domain. So as for now, those fundamentals are like how to implant those C2s and team servers in your environment and making it really work with the client side. Yeah, so I hope you got some clarification here, and I'm just moving to the next slide. If you have any question, you can drop out. Hello. Well, okay, there is no sign. Okay, moving to the next slide. This is like staged and non-staged payloads. So you'll be wondering, like, before in that conversation, like in the talk, I have been talking about droppers, unstaged, all this thing. So what is that actually? So basically, when we have a look into the payload, there will be two different types of payload. One would be staged and another would be non-staged. So what does actually it means? What does it mean by staged? So when it comes to non-staged one, it's like a whole shot. I'll be sending my entire payload in a single shot to the client, to a victim, and it will execute. But the larger size maybe get detected by the antivirus or in the network, and that's going to be it's going to be failure the most of time. So when it comes to red teaming, we follow staged payloads because obviously this is going to be less stable. I do agree with that, but as we discussed here, we'll be keeping our payload out there in different CND server or somewhere in the cloud, and we'll be calling that, and it will execute on every stages. So if you got an opportunity, you can just Google it. You can get to know how the actual metapredator stage works. So it's like sending the exploit in different stages, so it will be in multiple stages. So there is no straight away method. So this is the one of the most important technique when you are about to prepare for red team assessment. So it's not about preparing that particular payload. After working on the payload, you need to make sure how you are going to implant that payload in the client server or the victim. So yeah, so we have been discussing about, we will be sending some different files to the client and how to send it actually. So the most interesting way to send to the client is through Microsoft Office. Like you can make a Word document or either a Excel document. You'll be actually embedding those particular malware behind that macros. So you'll be embedding this malicious malware, and it's like something like I'm gonna install my particular thing that's going to call from that C2C server, and it interacts with that. It downloads all this thing together. So you were supposed to be make sure smart enough how to make the victim to click or either open that particular Word or Excel file, whatever you're about to send to the client. So this is the one of the interesting way. There are multiple ways to inject these things. Uh, as now, the most trending attacks that is really going with the Office, like people used to embed those macros, and those are vulnerable thing. They will embed it along with the Word file and they will send it to the victim. So yeah, here. So you know what? They do actually load some metadata examples, and that's gonna be execute all this thing. You know what? There is an issue actually. When you are trying to include a payload in that particular Word file and you're sending it out to the client, what happens here? Uh, it's gonna be a different mess here, because your antivirus will keep on looking into that. If it found something, it's gonna block it right away. So that's the reason we try to send an initiative that's gonna call the host, that's gonna interact with our command server, and it's gonna pull those payloads into the client machine. So we will be performing all those attacks in the RAM, not in the ROM, because you know what? Windows has recently improved their security mechanisms. So when we are pulling out in the RAM, so it's going to be volatile and still it's getting detected. So in back days, back to then, like people were using PowerShell because it was easy for them to execute. And nowadays Windows has improved the security, and recent days they started checking their memory. So it's like a AMC. So to avoid that, we started using our payload executables with C#. So it's hard to detect those payloads when it comes to Windows Defender or any other sort of the EDR which they're using. So meantime, we need to make sure those particular payloads being checked with different EDRs and different antiviruses. And before conducting any sort of attack, we want to enumerate the client in the proper way, so that we need to get to know what is the actual endpoints they're using inside that organization, what is the IDP they are using in the organization, what is the IDS, and what is the monitoring tool. And there are a bunch of things you need to make sure before performing any attack, when it comes to a team engagement. So there will be a lot of time we'll be spending with collecting those informations. Then you can able to proceed for the successful attack. So I'd like to discuss about one of the interesting thing what we can do with the this red team activity. So you might have heard about this process injection. It's like either like people might have really interested about dealer injection. So it's a very common one. So let's start here. Using one of the common technique is like a process injection. Goal is to inject malicious code by locating and inserting the code into the memory. So memory space actually, yeah. So legitimately most sources and then the process, that execute the malicious code. And we can find this technique in the different tactics. So there are two tactics that's been discussed in the military framework. One is like defense evasion, and which should be referring the model was trying to avoid detection. And there is another one thing called a privilege escalation tactic that is going to referring to the higher level permission in the system, like process injection can be performed in many ways. There are different workable approaches to inject that. So let's get into the general approach, how the process injection goes on here. Um, yeah, so when we look into the general approach here, like the malware process, you can see this fancy line, like which is gonna touch this malware malicious code. So let's call it like a launcher or loader. I'm going to inject my malicious code that execute, and we have a legitimate process such like any Firefox or either your Chrome or whatever. Your code will be injected, and that will run on the victim machine. Ultimate, our goal is like the launcher needs to first identify the process to inject the code, and this is done by enumerating process and process running on the system by where you keep it Sometime, instead of injecting the code, there might be an already running process like a malicious program. They launch a new process, then inject code into it. So it's like a high level, you can see malicious process, here, like I'm mentioning it, the strange arrow mark here. Yep. So that's gonna inject here. We'll have a look at this approach now. Now then, so here, when we come here, we can able to process the DLL injection. DLL is like a dynamic link library. It's a technique like it's similar to remote injection that connects and loads the malicious DLL inside the context of a legitimate process that's running within target again. So moving back to this DLL injection here, yeah. So this is how DLL injection goes on. So you know what? This is gonna connect and it's gonna run on the process. So as I said, there is a difference between this general approach and DLL injection. So specifically, talking about the injecting a DLL in path of the content of it. So before getting into that, there are some steps we need to perform, and we need to make sure you're familiar with the virtual memory concept here, because I'm gonna jump into virtual memory concept here. So here, so this is like the virtual memory. So people who don't know about virtual memory, I just try to explain it as much possible here, and I hope you will be getting something out of it. So yeah, so when you double click on the program, like it's like an opening sequence. It's a set of instructions the process created, right? You know what? Let's call it A. So this is this process A memory. You know what? A Windows operating system provide each new process created which is own private memory address space. So it assumes there will be, there is a own private memory space is there. This process is a part of virtual memory, and this is not a real memory. This is something like a illusion created by the operating system of the memory manager. This way, each process thing, it has its own private memory space. During that time, Windows Memory Manager, with the help of the hardware, translate the virtual address into the physical address in that, you know what, where the actual data is located. You can find that here. So it's like moving from here, and it's actually allocating the virtual memory. So that's how it goes on. So there is an important thing about the Windows Memory Manager. You know what? It translates the virtual address that we have in our physical address that can actually run. The same thing like the additional process. There are several multiple processes that will be running on the private space. The you know what this the whole number can be actually like there is a Windows Memory Manager, and with the help of the hardware, uh, we run normally and we deal with the memory addresses. So you can, when you are actually working with the debugger, you can get to know how this thing works. I know this is the more over high level concept, and it's really hard to understand, but I'm trying to make it as much easier for you to hear. So you're like, I need to give the overview of the from the step one to end step. We need to work on those things, and I need to debugger, and like it's a long way process. I'm not getting into that and mentioning to the so here in the memory process, yeah, we are talking about the virtual address and the physical address. Now you know what, and we are putting those virtual memory in the separated into the process memory that's related to space and user space, and the kernel memory which relate to the kernel space for the system space. So we have two parts in the virtual memory. We want to concentrate and focus on first process memory. That's what relevant to the injection technique. So let's deep down a little bit more on the process memory itself and try to understand that. So yeah, if you have the process memory, as I mentioned here, within the virtual memory. Now let's see what's a process memory. So then component which process memory has first one in the DLL. So here it's like the dynamic link library. This region represent all the associates with the process which gets loaded into the process memory when the process is created. Which means the process environment block, this PEB block, this particular PEB block contains information about the executable itself. When it's loaded, it loads the full path on the disk where to find DLL in the memory. So this process, there is the process heap, each process is like a single heap can create additional one if needed. Region specifies the dynamic input and the processes receives here. And you know what, this thread stack, this region, this particular region represent dedicated range of the process memory allocated to each thread on its own stack. So lastly, I already discussed about the process executables. Region contain the executable associated with the process. So you know what, a program runs a process, that process is created and executable associated with the program loaded into the process memory. So the virtual memory also contains the kernel memory. So these parts separated from the process memory but contains different components. Now, I hope we are familiar with the general process injection technique. You know what the virtual memory and what the process memory we are talking about, the DLL injection technique. It's, you know what, in this technique, the target is forced to load malicious DLL into the process. So we will be forcing that. So in the memory space again, in the memory space again, those remote process will, we got some questions here, just a second. Okay, yeah. So you know what, those forced process, so those malicious which is dropped onto the disk and the system is already existing, you know what, you'll be getting initial access technique that can be, you know what, you can find initial techniques in Metri framework, you can refer that. And you know what, that's really not relevant to us because now we are discussing about the process injection. So we'll continuing to the malware process, let's call it a launcher. You know what, that identifies the target process. Let's call the target X, which is a legitimate running process that gets on the process ID, so that you know what, you'll be surely exactly want to know that process ID of the target. So goal in the step to open a handler that will be here. Once again, I'm moving here, I'm sorry. So you know what, we'll be opening the handler, and those launcher can interact with the target system, target dot that exam files, and for this we have some specific APIs. So what is actually those APIs? You know what, these APIs will be monitoring in order to detect these kind of activities. So I mentioned this API. In this step, we need to place to inject the malicious code in our malicious DLL. The launcher locates the memory within target, for example, the legitimate process before allocating. In order to copy the full path of the DLL or the target process, we'll use the address for the allocated memory now just before the launcher exits and creates the remote thread. In order to make the target exit to execute a malicious DLL, we need to determine this address in the remote thread will start to execute. So you know what, this address is of the load library actually. So you know what, the load library function, this is important thing. So at this point, when we are mentioning the load library address, that's a really a successful thing. We are getting into that attack, and now we have our full path of the DLL into the memory. Our memory address would like to set and execute, and you know what, it can launch the exe that creates thread in the target process, and that will be executing that will be executing the our intentional task here. So you know what, the when we get the full path, you know what, the target process that always invokes the load library. So you know, will load the DLL itself in the process. So eventually, once the injection is completed, the launcher exits and closes the handle, and you know what, that's how the process injection is being completed, and you can perform really successful process injection with this technique. Moving on to the next slide. So antivirus evasion here, you know what, there will be, as I discussed, there will be different antivirus evasion techniques, and most of the antivirus will detect all these malwares and those sort of the malicious code through signature based, and you know what, every individual malware has its own signature that's being noted down by the antivirus software. So whenever you're sending it, it will detect, and you know what, that goes a massive storage database, you know, that checks those signature with hashes, and eventually if it's gonna flag it's a malicious, and it's going to remove right away from the system. So we need to make sure to avoid those malware, avoid those antivirus detection. So that's what I mentioned here. We can able to encode those malwares, and we can do some base 64, and we can do different encoding techniques, and we can club up. There are some people, they do a stigno, and I'm not familiar with the stigno because they keep on hiding those malwares behind the images, and they just send it right away to the victim. And if eventually victim opens that, perhaps it's done. So the entire system is being compromised. It will start executing it. You know what, once the image is open, as we discussed before in the topic, in the agenda from the coming down, it will call the C2 server, and it will download the malware from the cloud, the particular CND server where we are actually hosting the malware files, and that will execute on the victim machine. It's done. So this is going to happen. There are different evasion techniques that will be that will be discussed later on this in few further sessions. So how to avoid these things? So you know what, so the best way to avoid all this thing is like you need to uh, you know what, you need to keep updated with mal amc thing. And you know what, when if even we can patch those AMC things, but still, and you know what, it's not the proper way to handle those things, because in the memory still we can able to mitigate those things, and we can able to process those attacks successfully in the memory. So what is the best way to prevent? It's like you know what, event handler. So Windows got this event handler. So that's you know, that's a basic telemetry process. So whenever the event is created, and if it is suspectable, and you need to block those event. So this is one of the interesting technique to avoid these sort of red team activities in the organization. And yeah, going then um yeah going then, like you can make sure before performing any attack, try to enumerate as much as information possible, and try to gather all these enumerated details and make a map on it, and start executing your activity with that. And people who really attend the session, like I would like to explore you to Mitri a tackle chain. That's what we follow actually. So going through all these things, you can make yourself comfortable with the red team activities. So yeah, coming back, so there are few techniques what usually we do. Like this is the basic standard this thing what we do with that what do we do with this enumeration. So there is like something like passive technique. You know what, the goal is to uh, running some vulnerability scanners, and you know what, I will be getting some information on that. So but you know, the best way to get is through active this thing active techniques. So you know what, when you're performing active techniques, as we discussed, you know what, you will be including those templates in the document and linked images, and you can share some file. And you know what, you can able to make some executables like here I mentioned Windows Explorer, like yeah, Internet Explorer and Edge. And even you can make it work with the Firefox, either with the Chrome. What are the executables you want to work on that? Yes. So coming back, so this is the end of the session. We discussed about different approaches, how the red team actually work with the infrastructure, and how this payloads are being actually managed, and the basics of the antivirus evasion techniques and the process injection techniques. So we discussed plenty of things here. We got some chat here. Yeah. So bringing down, so this is the end of the session. So I hope you got some insight on this. So if you have any query, either you can drop a message, or you can as privately in the group forum. So I'll be answering in the group forum. You can find the slides in the group forum, and make sure you can find this recording in the YouTube. If still you have any queries with the red team related activities, you can drop a message, and you can find me in LinkedIn, and you can find me in different social media either. I'm the member of this DPF group, so you can you know what, if I'm not answering, like there are a lot of people there, it's like they can answer on that.